combinations. Here's how we do it. First thing is, just like before, graph the original shape. We're starting right now. And label. And it's probably going to be A, B, C, maybe sometimes a D. Whatever it says to label it that. So for example, it's going to be like A, B, C, dot, 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 whatever it says. Some of us are still forgetting to label. Let's work on that. Second thing we're going to do is do the first transformation. So there's going to be two. And label it. So we're just going to use the letters A, B, and C. If you have different letters, please use those. It's going to be A prime, B prime, and C prime, etc. Dot, dot, dot. That should not be new. Okay. You are going to say, do not go back to the original. You're going to use the new shape to do this second transformation. Should have made the box bigger. You're going to label this one in red. A double prime, B double prime, and C double prime. So instead of one apostrophe, since it's a second transformation you did, you give it two apostrophes, like little quotation marks. A is right one, up one. I'm actually going to do it here. B is 3, 4, right 3, up 4. And C is left 1, up 3. Remember, the most important part when we do this with patty paper is to make sure those dots are really obvious, to make sure they're correctly plotted, and that we have the X and Y axis. One sec. First thing it says to do is a rotation of 180 degrees. So you've traced with your patty paper the 3 points in the X and Y axis. So how many quadrants are you going to move, guys? I see people holding up 2. Yes, 2 quadrants, 180 degrees. Every 90 degrees is 1. Remember, where it starts does not count. So you're moving it 2 times. So let's do that on the whiteboard. We just did a rotation. That was our first transformation, and it ended up here. I'm going to go ahead and plot it on the board as well. And where's, oh no, this is C prime, isn't it? Dang it. And B prime is at -3, -4. Okay. Because things are about to get a little bit messy, here's what I would do. I would label on my graph, I would say this is the original, O. And this is the first transformation, 1. If that helps you to label it like that, please do so. So you'll notice I labeled rotation as transformation 1. I labeled it inside the triangle, and I put the apostrophes. But I know that that one with the O is the original. Do I go back to the original? Do I walk back to where I was and rotate? No, I do not. That would be ridiculous, and that would be a waste of time. Instead of going back, we're going to start where we are now. So we're just going to keep going from where we are. Next transformation is a translation. I'm going to do this one in black. And it's transformation 2. So I'm going to label it as such. We're going to go x plus 3, y plus 2. Could someone give me the directions for that? What does that actually mean? What does it mean, Francesca?
Up 3, over 2.
You're really close. It does go up, but flip that around. So it's x plus 3, so this is right 3 and up 2. You have two options. You can do it without patty paper or with patty paper. I'm going to do it without patty paper on the board. So I just take each blue point now, A prime, B prime, and C prime, and move it right 3 and up 2. So we'll start with A prime, right 3, 1, 2, 3, up 2, 1, 2. We'll end up right there at 2, 1. And I label it A double prime. Let's do the same thing with B prime and C prime. B prime goes right 3, 1, 2, 3, up 2, 1, 2. It says 0, -2. I'm going to do it with the patty paper in just a second. Last one, start at C prime, 1, 2, 3, up 2. It's at 4, -1. C double prime. And this is transformation 2. I told you it would get a little bit messy. It's going to overlap a little bit, and that's okay. Okay, I'm going to do it with patty paper on the board now, so if you want to do it that way, you can watch. Pre-image and image, congruent or similar? What do you think, guys? Congruent. Okay, when I ask pre-image and image, I'm talking about 0 and 2. So the original and number 2. So the very beginning and the very last one, they are congruent because they are the same size and shape. All you did was a rotation and a translation. You know that those are rigid transformation. Same size and shape. So then to answer the next question, since they are congruent, is it a rigid transformation? Yes, it is, because they are congruent. And red. Make sure your points are really obvious because we're going to use, if you want to use patty paper, you can. You do not have to on this one, actually, at all. So that's my transformation 1, and that's going to be labeled A prime, B prime, and C prime here in a second. Okay, we're reflecting over the x-axis, so I am flipping over where my arm is right now, flipping over the horizontal line. So it's going to go from here to down there. So remember, you can do this with patty paper and just flip horizontally down, or you can just count how far away it is from that reflection line. So I'm going to outline the reflection line in yellow. If it's 1 away from the x-axis for A, it's going to go 1 away on the other side. B is 1, 2, 3, 4 away. How many away on the other side, guys? If it's 4 away on this side, how many on the other side? 4. 1, 2, 3, 4. If you would prefer to do this with patty paper, oh, that's not 4. That's 4. You can label it B prime, and then C prime is going to be 3 away. Most of you guys get this part. It's the flipping it over the correct axis that we're having trouble with. It says X right there on the side, so read the axes. And go ahead and connect your dots. Okay, here's the original.
Oh, right. The
But here's the one that we're using. Tyler, what should we do?
Write the coordinates.
For what?
For the second shape.
Yeah. So for the one after the first transformation, we need to know the points for A prime, B prime, and C prime if we're going to use those points to get the third set of points. So up here, I'm going to write the coordinates for A prime, B prime, and C prime just by looking at my graph. Jovi, do you have those coordinates?
A is 1, -1.
Okay.
B is 3, -4, and C is -1, -3.
-1, -3.
Yeah.
Okay. C prime, -1, -3. You have to write these points down so that you can do the next step. So please write down the A prime, B prime, and C prime. The one in your homework is the exact same way. You have to write the second set of points down before you can do the dilation. Do the dilation now. It's transformation 2. We have to get A double prime. So William Landreth, what would A double prime be? And? Yes. So we're just multiplying all these points by 2. B double prime would be what, Olivia?
6, -8.
Yep. And C double prime, how about Elise, what would that be? Yeah. So now we got to graph those points. And then we will get our third shape, which is our second transformation, our transform shape. So 2, -2 goes right 2, down 2. It's going to overlap, which is why we connected those shapes right away. 6, -8, right 6, and down 8. And -2, -6 is left 2, down 6. Connect those. Make sure you label them with 2 apostrophes like quotation marks because it is a second transformation. Let's check it. Does that look about 2 times the size as the blue shape?
Yeah.
You betcha. So that is good news for us. That means the side length should be double the length. Let's discuss. We're looking at shapes. This is shape number 2. So the original shape after transformation 1 and shape after transformation 2. We're looking at 0 and 2 for this question. So the original and the second transformation. Are they congruent or similar? What do you think, Sebastian?
They are similar.
How do you know?
Because they're not the same size.
Yeah, they're same shape, but they are different sizes. So class, is it a rigid transformation?
Yes.
No. It's actually not. It's okay. No problem. Why is it not? Could someone explain to me? Grace, why is it not a rigid transformation?
Because they are not the same size.
There you
and
go.
I screwed up.
It's not a problem. No, you caught your mistake, which is good. No, because they are not the same size, meaning they are not, what's the word I'm looking for? Congruent. Because they are not congruent. They are similar. So whenever you have a dilation, maybe you're catching on to this. If you have a dilation, they're not going to be congruent.